So one of the things that we need to work on and really try and have a good understanding of, which is difficult, is the sandwich theorem. And we're going to look at it right now with limits. We'll look at it later in different applications of calculus. But if we can get to the point where we are able to solve some of these more complicated limits using a sandwich theorem, then it can really kind of make life nice if we understand how it works. So what we're going to do is we're going to look at the sandwich theorem here, and we're going to talk about how to use the sandwich theorem with the limit of as x approaches negative infinity of 1 minus cosine x over x squared. And the way to start this out is to just think, hey, how can I separate this guy out? Like, what's going on here? And what's going on is you have 1 over x squared times 1 minus cosine x. So I'm just going to rewrite this with two separate pieces. And then for my sandwich, I'm just going to use this guy in the front. And I'm going to look at, and if you'll graph this, you're going to end up with negative 1 over x squared. We're going to graph that. And that will be less than or equal to 1 minus cosine x, which will be less than or equal to 1 over x squared. So the thing that we're in, and I'll show you a graph right now as well so that you can see kind of how these graphs look. Then take the limit just of that front guy and take the limit just of this back guy, and these become the outer edges of the sandwich, and whatever happens in between them has to stay between them. So if this first limit, the limit as x approaches negative infinity of negative 1 over x squared, that's going to go to 0. All right, and then on the other side, the limit as x approaches positive infinity of 1 over x squared, that also goes to 0. And so since these two guys both go to 0, this middle player is in between both of them. And since he's in between both of them, he also has to go to 0. And so we can say this. By the way, we should really look at that guy as over x squared. Okay, the whole function, this whole function here, has to be in between this whole function. So that's how you use the sandwich theorem. It's kind of a tricky little theorem, but it comes in really, really handy when you need it.